Okay, good evening everyone. Just read a see this is a concept of carbon anion. Okay, how much you know that this carbon anion means what? What is the definition? It is that gain that carbon contain the negative charge. Okay, second point it is that it is gain the extra electrons. And third point it is that it is contained that it makes a lone pair of electrons and it is lose that positive charge on that carbon positive groups. We have to lose that positive groups and it makes that highly reactive. It is a lone pair of electrons is given or that's make it is a highly reactive. These are the points definition of that carbon anion. Let's move on that it is a stability, it is a formation of carbon anion. How to form that carbon anion? Just try to take the simple reaction. It's a carbon CH4 is a react with that base to produce that CH3 lose the protons in that heterogeneous cleavage to formation of that electron pairs. Okay, here to form the electron pair, this CH3 negative charge will be formation and plus
okay, we have
H
to
plus
that
will be formation. This is a simple
how
reaction. How it is that identify that increasing order of that carbon anion case. Okay, just try to see that more delocalization is a more resonance. It is a resonance case. It is that highly stable, like benzyl anion. This is a more delocalization given. No, that's why it is a highly stable. And second, it is. Okay, we are talking about that electron withdrawing groups. This is that electron withdrawing group in inductive effect. These are that highly stable compounds. In a highly stable carbon anion, we can say it is. And third, we have to move on that a solvent given. Like we do is the polar solvent. This is polar solvent is that this is the highly stable compounds, the highly stable carbon anion, we can say it is. Now we are talking about that hybridization, which one is that come at the first position, sp is that come first, sp2 second and sp3 is the third position. These are the stabilities of that carbon anion. Okay, just try to see this question asking about that stability of carbon anion. Okay, we have to see that three options given and which one is that come at the first position. Okay, cyclopropyl anion given. This is a angle strength present. This is a highly angle strength. There is a no resonance. It is electron donating group effect of this ring. Okay, that's why it is a sp3 hybridization given. Okay, this is why this is a three main reasons, and that's why this compound is considered as an unstable compound, highly unstable compound. This is cyclopropyl anion. Where to move on, the second option is that. Okay, this is a second option. We have to see that resonance. This is three carbons given. This also show that sp2 hybridization. This is a resonantly stable this compound. We have to three carbons is this compound contain the resonance stable. From these three carbons given. Okay, this is a stable compounds, stable carbon anion. Okay, we have to see that third option is given. This is a 6 pi electron is it's a highly conjugated, and if we have to apply that Huckel's rule, it contains the 6 pi electrons. This is a highly aromatic. It also contains that sp2 hybridization. This highly stable compound. Okay, correct stability of that carbon anion is the correct option is that option number C, option number B and option number A.